All right, so last time we took a look at graphing equations, and those ones took a little bit longer because we were plugging in points and then we had to plot the points. So now we want to take a look at slope so that we can learn a faster way of graphing lines using the slope and the y-intercept, which we'll do in the next section. So let's go ahead and start off with the definition of slope. So the slope of a line, and other types of graphs do have slope, but if it's not a line, the slope is constantly changing because it could be going in some kind of curve like this. And slope describes how steep the line is, or its slant. So with a line like, or with a curve like this, it's always changing because some parts are more steep than others. But with a line, it's going to be, well, a straight line is going to be constant all the way along because we're not changing how steep that line is. So just finishing up this definition, the slope of a line is its slant or steepness. And this next part's important for when we start looking for slope from a graph. From left to right. Always finding it from left to right. So the first definition we're going to use, or the first equation for slope, is the vertical change in y, because our y is our vertical axis, or the rise over the horizontal change in x, because our x-axis is horizontal. And this is our run. So you run horizontally, you rise up and down, so rise over run. And so first thing we want to do is find slope from a graph. So this is the part that's usually a little bit easier. And we're going to do this, and then we're going to use what we do in finding it from the graph to find a general equation for slope given 2 points. So let's go ahead and look at a couple of examples. And I'm going to be drawing graphs, so if you have graph paper, I would definitely use the graph paper now. It's going to make it easier to see what our rise and our run is. The way I'm doing it's going to look a little bit messy, so I apologize. But I don't have graph paper on here. So number one, I'm going to draw our axes first. So remember, x is horizontal, y is vertical. And we're going to have 2 points on our line. We're going to have -1, -1, 2, 3, 4. And I'm going to go ahead and label that as -1, -4. And our second point is the point 1, -1, so right 1, down 1. And then I'm going to draw our line through those 2 points. It's not wanting to. Let me try this one last time. And we'll say that's good enough. Okay, so we have our line. Now we want to figure out what the vertical and horizontal change is. So our slope is equal to the vertical change. So if I'm going up here, I want to know what that vertical change is. So we start down at -4 and we go up to -1. So we go up 1, 2, 3. And it's up, so it's positive. And so remember what we did there? We went from -4 up to -1. And so to find the difference of those, remember difference is subtraction. So if we subtract those, -4 minus -1, if I go ahead and add those together, we get -3, which is still 3, and we'll talk about why it's positive versus negative when we get to some other examples. And now if we go ahead and look at our horizontal change, we're going from an x coordinate of -1 to 1. So that's a change of 1, 2. So that's our horizontal change. Again, if we subtracted 1 minus -1, we get 1 plus 1, which is 2, which is what we get right here. So the order in which you subtract them is going to make a difference. So just remember, if you're finding it from the graph, if you're going up and to the right, it's positive. If we were going down, it would be negative, or if we were going to the left, it would be negative. But you always want to go from left to right. So we don't really want to start at this right point and go to the left. But you can, as long as you match both of your sides accordingly for which direction you're moving. All right, so that's our slope for this one. We end up with 3/2, and it's positive because our line is going up to the right. Now let's go ahead and take a look at another one with a negative slope. So I'll go ahead and draw our axes again. And we're going to have the points 2, 2, so right 2, up 2. I'll label that one. And the point 4, -2, so right 4, and then down 2. So this is 4, -2. And again, I'm going to draw our line through there. All right, so we want our vertical change and our horizontal change. So remember, from left to right, if I'm starting at this point here, our vertical change is how far we're going down. So since we're going down, it's going to be negative. We start up at 2, and we go all the way down to -2. So that's a change of 1, 2, 3, 4. So -4. And since we're going from left to right, our horizontal change is going to be positive since we're moving to the right. So for the horizontal change, we start at 2 and we go to 4, so that's a change of 2. As our slope here, we can just divide this. -4 divided by 2 is -2. So notice how this line on the left is going up to the right, positive slope, down to the right, negative slope. So we're going to go ahead and characterize or summarize all of our different types of slope once we look at our 2 special cases. So let's go ahead and look at what this looks like in general. So if we're not given a graph, we're just given 2 points. We can follow this formula. So I'm going to go ahead and draw our axes. So let's say we have these 2 points, and I'm just going to roughly draw our line through here because we're not given specific numbers. But we're given 2 points. The first one is going to be the point x sub 1 and y sub 1. And the second point is x sub 2 and y sub 2. So when you have those numbers down at the bottom, they're subscripts. So we say x sub 2, y sub 2. Sometimes I'll just shorten it down to x1, y1, x2, y2. Perfectly fine. So what we want to do here is we're going to find our slope, and we're also going to call our slope m. And so this is how it's going to show up in our equations. So I'm going to stick to m from now on. And so if we're given 2 points, x1, y1, and x2, y2, we want to know our vertical change and our horizontal change. And our vertical change is how much the y is changing. So we're going to take our y's and subtract them. So y2 minus y1 over the change in our x's, which is going to be x2 minus x1. And so notice how you have both of the y's on top, both of the x's on the bottom, and they kind of match up. So the 2's are both together here, the 1's are together here at the end. You don't want to mix those up, so you don't want to have y2 minus y1 and then x1 with minus x2. Then your pairs aren't matching up. But you can switch this around. So if you wanted to do y1 minus y2 over x1 minus x2, that's perfectly fine because they're still matching up. It's just going to switch your signs, but it won't switch the sign of the overall answer. So we'll go ahead and take a look at one of those in a second here. So some examples. We're told to find the slope of each line. All right, so number one, let's go ahead and look at the points 6, -2, and 5, 4. All right, so if you want, you can go ahead and label these as x1, y1, x2, y2. Make sure you're not putting x1 and x2 together. These are still x, y coordinates. We're just labeling them as point 1 and point 2. That's all the 1 and the 2 are for. So now let's go ahead and find our slope. So m is equal to y2 minus y1. So we have 4 minus -2. So be careful with your signs. I'm going to put that -2 in parentheses. Over x2, which is 5, minus x1, which is 6. And now let's simplify. So simplify the top and the bottom separately. So 4 minus -2, we can go ahead and add the opposite. So 4 plus 2 gives us 6. 5 minus 6 gives us -1. And always simplify all the way down if you can. So 6 divided by -1 is -6. All right, let's go ahead and take a look at this one the other way around. So if I were to go ahead and do y1 minus y2, x1 minus x2, so do them in this other order here. Let's just see, just to make sure that we get the same answer. So y1 is -2, minus y2 is 4, over x1 is 6, minus x2 is 5. -2 minus 4 is -6. 6 minus 5 is 1, and -6 divided by 1 is still -6. So see how it just put our negative on the top instead of on the bottom? If you had a positive number, instead of having, let's say we had a +6, it would be 6 over 1 versus the other case would be -6 over -1, -1, not -6. But this would still give us the same +6. So that's the case where you have a positive slope. With negative, it's just going to move the negative from the bottom to the top or the other way around. But we get the same answer. So I would just pick a way that you like better and stick to it. I'll usually go the normal 2 minus 1, just because that's kind of the standard way of finding slope. All right, let's try another one here. 6, -8, and -2, 4. All right, so let's go ahead and find our slope. So we're going to have our x1, y1, and x2, y2. And if I subtract these, we're going to have y2 minus y1. So 4 minus -8. Again, be careful with your negatives. And then -2 minus 6. All right, so we can add the opposite on the top. So 4 plus 8 gives us 12. -2 minus 6 is -8. And now when you have one like this where it doesn't divide in evenly, you do not want mixed numbers. Because if we were going to go ahead and graph this, a mixed number will give us a faint idea of what the line is supposed to look like. If it's a really big number, it's really steep. If it's small, then it's not as steep. But it doesn't tell us the rise over the run because there's a whole number out in front. Always leave these as improper fractions. So I'm just going to reduce this down. So we get 3 over -2. And remember, this is going to be important when we start graphing. You can leave the negative on the bottom, or you can move it up top, or you can put it out in front. But for graphing, it's going to be easiest if you leave it as one of these first two, because it's going to tell us if we go up or down, left or right. And if it's out in front, it can be a little confusing to see which number you're going to put the negative with, because it has to go with one or the other. Remember, it can't go with both because a negative over a negative makes a positive. So it's not -3 over -2. All right, let's try 2 more. So these ones are going to be our special cases. And so this first one, we're given the points 2, 5 and -1, 5. And so let's go ahead and find the slope just like we've been doing, and then we'll see what kind of line we have. So y2 minus y1, so 5 minus 5, over x2 minus x1, so -1 minus 2. That's one other thing you can do when you're going through and subtracting. Underline or cross out just something so that you don't use the same numbers again. I've seen that where you're kind of mixing up what you've used. So I like to go y2 minus y1, x2 minus x1, just so you can kind of pair them up a little bit better. So if we go ahead and simplify, 5 minus 5 is 0, -1 minus 2 is -3, 0 divided by any number is 0. So this one we have a slope of 0, and if I were to graph, just roughly graph these points, 2, 5 means right 2 up 2, 3, 4, 5. And -1, 5 means left 1 up 5. And see how we have this horizontal line going through these 2 points. So, as an important note here, all horizontal lines have a slope of 0. And so there's going to be a difference between a slope of 0 and our next slope that we're going to look at. So these are our horizontal and vertical lines. This one has a slope of 0, and all horizontal lines do, because there's no vertical change. So that top part of the fraction is always going to be 0, no matter what. Number 4, let's take a look at the points 3, 1, and 3, -4. And so again, let's go ahead and find our slope. So y2 minus y1, -4 minus 1, over x2 minus x1, so 3 minus 3. And so on top, -1 minus 4 is -5. So we have a vertical change, but our horizontal change is 0. And what is any number divided by 0? Well, we can't say how many times 0 goes into -5, so this is undefined. And if we go ahead and look at this graph, we have the points 3, 1, so right 3 up 1, and 3, -4, so right 3 down 4. And we have this vertical line that goes through those 2 points. So because it's a vertical line, there's not going to be any horizontal change. The denominator is always going to be 0, which means we always have an undefined slope. So all vertical lines have an undefined slope. And let me go ahead and underline some things up here. So horizontal lines have a slope of 0. Vertical lines have an undefined slope. All right, now let's go ahead and categorize what we have. It's really important to be able to identify what kind of slope you have, because if you're given a slope and you graph the line and you were given a positive slope, but your line is going down to the right, then you know something went wrong, because like we saw, a positive slope should be going up to the right. So I'm going to draw 4 sets of axes. So we have 4 types of slope. And I'm just roughly drawing these. These aren't, we don't need to see specific numbers on here. So if we have a positive slope, we're going to have a line going up to the right. We have a line going down to the right. Remember, it's always left to right. This one's negative. A horizontal line. I'm going to write horizontal up here. And remember, horizontal lines, try to think if they have an equation for just an x or just a y. This one's just a y, so y equals some number because our y value is not changing. This has a 0 slope. And if we have a vertical line, and vertical lines have the form x equals some number, we're going to have an undefined slope. So these last two, if you can get these memorized, it's going to make your life a lot easier when you see questions relating to vertical and horizontal lines. Because most of the time, all they can really ask you about is the slope of the line or what the equation or graph might look like. So try to get these two down. It's going to be really helpful. All right, so now let's go ahead and take a look at our last, second to last section here. Finding slope from an equation. All right, so the big equation you need to know, and you have to know it now, you're going to have to know it in Math 96 and 120, is the equation, if you don't already remember it, y equals mx plus b. And this is our slope intercept form of a line. And so this is called slope-intercept form because this m right here is our slope. And then like we'll see later, it's not important right now, this is going to be our y-intercept. So if we're told to find the slope of a line, and we're just given an equation, if we can get it into this form, all we need to know is the coefficient of x. Let's go ahead and look at some examples, and we'll start off with an easy one. So examples, find the slope of each line. And so number 1 here, we're given y equals negative 7 over 2x plus 1. So this one is super nice. It's already in y equals mx plus b form. And so our slope is just the number, fraction, whole number, whatever it is, in front of the x. And so our slope, or m, is negative 7 over 2. And you're going to keep whatever sign is in front of that. So that one's super nice. What about if we're given one where it's not already in this form? So let's say we're given 4y equals 4x minus 3. Then what we want to do here is we want to solve for y. We want to get y by itself so that we're in the form y equals mx plus b. All we need to do here is divide both sides by 4. And this is why we got practice in, can't remember what section it was, but one of the sections where we were solving equations, I think it was 2.4, 2.5, for one of the variables. So since we're dividing both sides by 4, we want to divide the entire right side by 4. And so what I'm going to do is we're going to split that 4 up. We're just going to divide every single term by 4. So on the left, we're left with y. Same thing happens with our x's here. So 4 over 4, those are gone and we're left with x. And then minus 3 over 4, I'll write this as minus 3/4. So now what is our slope? What is the number in front of x? Well, if we don't see one, we have a slope of 1. Which makes sense because 4 divided by 4 is 1. All right, let's go ahead and try one more of these. And I'm actually going to put this one over to the right because it's a little bit longer. Number 3, we're given 5y minus x equals 10. And so we're getting y by itself. So first thing we want to do is get rid of the terms furthest away from the y. So I'm going to get rid of this x. I'm going to add x to both sides. And so this is the part where before I said we could write this in any order on the right side here. So we could put 10 plus x. But in mx plus b form, the x term comes first. So let's go ahead and put this positive x. It's a positive 10, so plus 10. And then we're left with 5y on the left. And then divide every single term by 5. And this one's a little bit trickier. So on the left side, we have y. On the right side, x over 5, we want to write this as a coefficient of x. So we saw this once before when we were finding coefficients. Remember, the number in front of x right now is a 1. So I'm going to write this as 1 over 5x, or 1/5 x, plus 10 divided by 5 is 2. So now our slope, or m, is the number in front of x, so it's 1/5. All right. Our last part of this section is still using slope, but we're going to use it to figure out the relationship between two lines. And so before we get to that, we need to go ahead and write down just a couple of definitions. And so our first definition here is for parallel lines. And so parallel lines have the same slope and never intersect. And so the only way the two lines can never intersect, so if we have a line going up here, another line going up here, these are never going to intersect because they have the same slope. So let's say this top line has a slope of 2, this bottom line will have a slope of 2 also. And we're going to show this part, you don't really have to know, but you can show the parallel lines are parallel by putting these arrows on them. You might remember that from geometry. But again, you don't need to know that. The important thing to know is that they have the same slope. And so the way I remember that these are parallel lines is the two L's in parallel make parallel lines. So we have one more definition to look at. And our next definition is for perpendicular lines. And so perpendicular lines . have what we call opposite reciprocal slopes. And they intersect at a 90-degree angle. So, opposite reciprocal slopes, opposite means one's going to be positive, one will be negative. And then reciprocal, think like 1/2 and 2/1. So they're going to be flipped. But one of these would be positive, one would be negative. So let's go ahead and just draw out what perpendicular lines look like. The axes, the x and y axes, are actually perpendicular lines. They intersect at a 90-degree angle. And because they're perpendicular lines, let me draw this a little bit better so you can see what I'm talking about with the slopes. If I draw like this and like this. One of them is going up to the right, so it's positive. And then in order to have perpendicular lines, the other one has to go down to the right, and it has a negative slope. And if you wanted to go through and figure out why they have opposite reciprocal slopes, or specifically reciprocal, it's not too bad to see. I'm not going to go through it in this video. But let's take a look at one more example of perpendicular lines, or what the slopes would look like. Let's say we had the slope, let's go with 6. It's a tricky one. We need the slope of the perpendicular line to this one. So it's going to be the opposite, so it's going to be negative. And if we flip our fraction, we get 1/6. So these would be the slopes of perpendicular lines. And now let's go ahead and just look at a couple of examples of how to determine, based on the equation, if we have parallel or perpendicular lines. So we want to determine whether the lines are perpendicular, parallel, or neither. Because our two lines, some of them will be parallel, some of them will be perpendicular, but they don't necessarily have to be one or the other. They could intersect at an angle that's not 90 degrees. So let's go ahead and look at our first one here. So we're given the equations x plus y equals 6 and x plus y equals 1. So using what we just learned, we want to first get these into our slope-intercept form. So we want to get the y's by themselves. So I'm going to actually rewrite that second equation off to the right. And I'm going to solve for y on both. So I'll subtract x. And again, I'll leave the y on the left and then put them in mx plus b form. So negative x plus 6. And our second one will also subtract x. So we get y equals negative x plus 1. All right, so now the slope for each of these, the slope for this first one is our coefficient here, so it's negative 1. And it's the exact same thing for our second equation. It's also negative 1. So since they have the same slope, we have parallel lines. All right, let's try another one. So this next one, we're given 3x minus y equals 4. And x plus 3y equals 9. So let's go ahead and do the same thing and get y by itself. So I'm going to subtract 3x on the left and right of the first equation. We get negative y equals negative 3x plus 4. And now we want to get this y by itself. You can either change all of the signs, or think of this as dividing by -1. Divide every single term by -1. So we get y equals positive 3x minus 4. And so our slope for this first equation is 3. And our second equation, let's go ahead and subtract x. So we get 3y equals -x plus 9. This plus or minus here just depends on the sign of the number. And now if we divide every single term by 3, we get y equals, remember this has an imaginary 1 in front of it, so -1/3 x plus 9 divided by 3 is 3. And so our slope of this line is -1/3. And so you want to take a look. They're not the same, so they can't be parallel. They are opposites of each other, and 3 and 1/3, if we think of this as 3/1, those are reciprocals. So these are opposite reciprocals. I'm going to abbreviate that to REC. And so since they're opposite reciprocals, that means we have perpendicular lines. And one last example, so you can see the case where we have neither. 3x minus 7y equals 35. And 7x minus 3y equals -6. So just looking at these numbers with the x and the y, they look similar, so it looks like there should be some kind of special relationship going on here. Let's go ahead and solve for y and see what we can see with their slopes. So in this first equation, let's subtract 3x. And so we get -7y equals -3x plus 35. Divide every single term by -7. And so we get y equals -3 over -7, we can't simplify, but a negative over negative is a positive, so 3/7 x. And 35 divided by -7 is -5. So our slope here is 3/7. And our second line, let's go ahead and subtract 7x. So we have -3y equals -7x minus 6. And now divide every single term by -3. And we get y equals, again, negative over negative is a positive 7/3 x. And then -6 over -3 is positive 2. And so our slope here is 7/3. All right, so if we look at our two slopes here, even though we have reciprocals, they're not opposites. So we have reciprocals, but not opposites. So since they're not the same slope, they're not parallel. And since they're reciprocals, but not opposites, they can't be perpendicular. And so there's no special relationship here. So they're neither parallel nor perpendicular. We just have two lines that intersect, but they do not intersect at a 90-degree angle. And so next week, we're going to get started on 3.5, and then we'll be done with chapter 3. And we're going to talk more about slope of a line and finding the equation of a line and graphing them.